Now, when the sun is high up in the sky, there's a lot of heating per unit area of the ground, okay? You can see that in this diagram here. When the sun is high, a beam of light, a cylindrical beam of light, illuminates a relatively small area, so the amount of heating per unit area is large. When the sun is low above the horizon, that same beam of light gets spread out over a larger area, so the same energy is spread out over a larger area. You get less heating per unit area, and the days are generally cooler in that case. Now, a lot of people think that, well, sure, it's the tilt of the Earth's orbit, it's the tilt of the Earth's axis of rotation that causes the seasons, but they incorrectly think that the main effect is that when the Earth is tilted toward the sun, the northern hemisphere is slightly closer to the sun, and that causes greater heat and all that. That's a totally minor effect. The Earth is 24,000 Earth radii away from the sun. So any additional tilt toward the sun brings it only a slight amount closer to the sun. So that's a negligible effect. Rather, the tilt gives you sort of more direct heating, more light per unit area, as illustrated in that previous example. Another thing people think is that, well, given that the Earth's orbit is elliptical around the sun, maybe you get a lot of additional heating when the Earth is close to the sun versus farther away. Well, the Earth's distance varies from the sun by only about 3%. So that's not a major effect. It's a bigger effect than the one I just talked about, the extra amount of heating from the Earth being a bit closer when it's tilted, but it's still only a 3% effect. It turns out that, in fact, Earth is closest to the sun during the northern hemisphere winter. Around early January, Earth happens to be closest to the sun. So that gives you a little bit of extra heating, and that mitigates the seasons a little bit. It makes the winters in the northern hemisphere slightly warmer than they would otherwise have been. You might think it should make the summers in the southern hemisphere even hotter than they would have been otherwise. But in the southern hemisphere, you have a lot more water, fewer continents, less land area than in the northern hemisphere. And water tends to heat up and cool down more slowly than land. And so the southern hemisphere doesn't get affected by this extra 3% very much.